should be able to go through this reasonably quick, I would think, because I feel like a lot of it is similar.
Oh yeah, we didn't.
Yeah, I want to, and I don't, I'll be honest, there are times that I skip the end of notes and just don't go back and do them, and I'll tell you that in advance. But there are also times that I do go back, so. Okay. Example 4, the traffic pattern of departing flights at Orlando International Airport on a fall afternoon can be modeled by the function v, defined by v of t is 92 minus 15 sine of t over 3, where v of t is measured in vehicles and t is measured in minutes, where t is between 0 and 30. Okay. A, what are we doing when it says find v of t for t equals 18?
Plug it in.
You're plugging it in, right? And so you're doing 92 minus 15 times sine of 18 over 3. Not that I even had to write that piece out. Now, obviously, calculator problem here, yes? Okay. If you want, you might want to consider, because we are going to graph this. If you notice there's a graph, and you know this is an A, B, C, D, E problem. So you might want to just go ahead and put it in on Y1. That way you don't have to type it in a bunch of times. If I type my, equation in, 92 minus 15 sine of t over 3. So now it's in Y1 if I want to use that. So I can do alpha, trace, or at least that's how I get to them. I know there's somewhere else. Parentheses, I'm plugging in 18. There's 2 reasons you might not have gotten it. A, you might have typed the equation in wrong. And B, sine is in this problem. If sine is in this problem,
Oh, I knew.
There we go. You'd be radiant.
you'd be in radians.
I feel like I kept doing that.
Was that changing
Are you-
from Y? But I'm in.
Yeah, you need to change your mode. You're still in like polar mode. We need to be in, what is it, function, I think? Yeah. That was the last thing we did last year, pre-calc. So you got your calculator here.
Yeah.
Because I know what, I think Caitlin, you had to change the calculator you were using yesterday. It's in your room somewhere. I can
I
almost
know it's
guarantee.
in there. I just don't know where I put it.
You just have to look. Okay, now did everyone get the answer?
Yeah.
96 point what?
19.
Minimum 3 decimal places. So 191. Now, I will see, it depends on the situation, what they ask. What is this representing? Yeah. So this V of 18 is the number of vehicles at 18 minutes. So depends on the scenario. Sometimes you can, I mean, we could to an extent say that this is about 96 vehicles. Just kind of depends on the scenario though. Okay. B, make a sketch of the graph of time versus number of vehicles. Be sure your graph has a scale. Okay. This is not something I recommend graphing by hand. Okay. So we're going to graph it on the calculator. I personally have a lovely blank screen. Do you guys have a lovely blank screen? Okay. Thoughts?
Zoom out.
Okay. So zoom out could be an option. I'd be tempted. I don't know. I'm trying to remember what we've talked about in pre-calc. I have a love-hate relationship with ZoomFit. Have we used ZoomFit?
Mm-hmm.
Okay. ZoomFit is option 0, I think. I mean, you're going to have to just mess with the graph, okay? ZoomFit is option 0. Below 9 there. I have a love-hate relationship. Sometimes it does good things. Sometimes it does bad things. This is kind of looking more like good things because I can see a graph now, yes.
Mine like 3 seconds. Said Zoom fit.
I did ZoomFit.
Go all the way down.
What's that?
It's option 0 if you go down below 9.
What are you talking about?
Did you try just zooming out? I'm curious.
Yeah, you have to zoom out twice.
Okay.
Look,
Does it work though?
yeah, give it here now.
Yeah, you still have nothing on the first one. Huh. So, zoom out kind of works. I still like my ZoomFit better. Just because it, Now,
What did you change?
with this in mind, folks, which part of the graph do we need to look at?
The top, right?
Which part, where are we concerned about? We're specifically talking about V of t, and it says where V of t is measured in vehicles and t is measured in minutes from 0 to 30. Do I care about anything outside the minutes range of 0 to 30?
Mm-hmm.
No. So now that I have a graph to look at, one thing you might want to do is in window. Remember, I can go into window now and change some of this. My x-min and x-max left to right is -10 to +10. I don't need to go left 10 and right 10. I need to go 0 to 30. Okay. Now, the only thing is that kind of makes it look like it go all the way down to the x-axis, but it doesn't go down all the way down to the x-axis, does it? Okay. So, in order to find out some of those values, you could do a trace. You could do like some mins and maxes. Like right here, I can see this goes what? Maybe almost 107 high. Which honestly, for sketching a graph is good enough. This doesn't go all the way down to 0. This goes down to, looks like around 77. So you can use those type of things, you can use trace to kind of help you sketch the graph there. So, now it says be sure your graph has a scale. You should always have a label. This bottom axis, the t-axis, is what? It's going to be time in minutes. My left is V of t, which is vehicles. Okay. This doesn't have to be drawn. I mean, technically, that lowest piece is 77 up. You don't necessarily have to do that, but I do know, like I think on mine, I did like 77 here. It's labeled as long as it's labeled and there, it's good. Actually, you know what I might do? I can see my graph here. I might just draw this in and then go back and label. Okay, knowing that this key place I went down to was 77. What did I say this height was? 108, I think, was the highest point. You might also look, where does it intersect the y-axis? So if I trace over that way, it intersects the y-axis at 92. And then you definitely need some labels. You don't have to label all 30, but, you know, maybe if you kind of figure out 10, 20, 30, or 5, 10, 15, 20, 25, 30, something, you know. I don't know, looks like 10's about the middle piece there. So basically it's divided into thirds, I guess. 20's a little lower, so, you know, it doesn't have to be too specific for this purpose. So, but always be sure appropriate labels, units. Okay. Get what you need on that graph. Okay, have you looked at C? What is the average rate of change of the vehicles at the departing flights over the time interval 15 to 20? Indicate units of measure. What am I doing here? Find the keywords in that question.
Average rate of change.
There you go. You saw it. Maybe you saw that a few times in homework. Okay. They're saying find AROC. How do we find AROC?
V of 20 minus V of 15.
Uh-huh.
20 minus.
Right? It's like doing slope. The y minus y over the x minus x. They gave us the interval of 15 and 20. So we know our denominator is 20 minus 15. On top, you're plugging in v of 20 minus v of 15. Okay? That's plenty enough work when it's a calculator active problem. This is a calculator active problem. Okay? Did we already have this equation plugged into y1?
Yes.
Yeah, so use it to your advantage, right? This stinks, doesn't it?
Gosh, dang it.
Are we getting it?
Eventually.
And it's not that you have to be as quick as the rest of the class. It's just you have to be able to do it, right?
Yes.
Are you getting my answer? How do you feel about this negative?
I feel like it scares me.
I thought I did it wrong and I got negative. I feel like
Why am I not scared about the negative?
it's going down.
Okay.
Oh yeah.
Time interval 15 to 20. Well, and this is, you know, ish. That's guess, you know, that's estimating. The average rate of change, that's decreasing, isn't it? So does it make sense that because if you're going 15 to 20, basically it'd be finding the slope of that line right there, give or take. Okay? So that's what we just did for AROC, is we found the slope of that line. Okay? So the average rate of change on the interval 15 to 20, what is it doing? The negative indicates that it is decreasing. And we're decreasing at approximately, 3.999. So that's about a rate of 4 what? Vehicles per minute. Okay.
Now the pendulum question is
Is this what you needed to do one of the homework?
I got the reasoning wrong because I didn't understand. I thought the negative meant that it would be like
Okay, so the average rate of change on the interval of 15 to 20 minutes is decreasing. I need to somehow indicate that negative, because you're not going to say the average rate of change. Like if you're putting it in words, you know, sometimes you have to put the stuff in words. If you're putting it in words, you're not going to say the average rate of change is -4 vehicles per minute, you know, or it's what the average rate of change on 15 and 20 minutes is -4 vehicles per minute. What, you know, what does that negative indicate? So decreasing at a rate of approximately 4 vehicles per minute. And again, as I said, the negative is the reason for decreasing. Okay, I get it. Negatives can be scary and they can make us think we're wrong, but look at the scenario. Okay, average rate of change. Could that be negative? Where's that on that graph? Oh, that average rate of change being negative makes sense. Okay. D. Estimate the instantaneous rate of change of vehicles at t equals 18 by finding the average rates from t equals 18 to 18.1 to 18 to 18.01 and 18 to 18.001. What are we doing? What we did, right?
Mm-hmm.
In other words, for this first one, what would you be plugging in?
Yeah.
Okay. You want to know the answer?
-4.82.
You have 4.823, and that is, what's my label here? Oh, it's still vehicles per minute, yes? Anyone have the answer for the second box?
-4.803.
You have 4.803 vehicles per minute. Sorry, I'm trusting you guys can plug this into the calculator, right? We've done enough of this between yesterday and then you had to do some of this in homework, I'm guessing. So, and the third one?
-4.801.
Are we converging on an answer here? Yeah. Okay, that definitely looks like it's converging on the answer. So the instantaneous rate of change, or the IROC, at t equals 18 is about 4.801 or 4.8 vehicles per minute. What's it doing though? It is decreasing. Does it make sense at 18 that it is decreasing? Yes, because that's just in that interval we are just in. We just looked at the graph. Oh, 18 is going to be in this decreasing section. It all flows together. Okay? So, IROC at t equals 18 minutes is decreasing at approximately 4.801 vehicles per minute. Okay. Why can't the instantaneous rate of change of traffic in the departure lane with respect to time be calculated using the method in part C?
Because it's not over an interval. It's just at one point in time.
Yeah. And if it's just at one point in time, you would end up doing V of 18 minus V of 18 over 18 minus 18. Yeah, it doesn't work when it's just at an instant. We'll talk about later 0 over 0, what that form means, okay? But, if nothing else, my denominator is 0. So the big thing I keep coming back to is division by 0 would occur. And we can't have division by 0. We know that as calc students. Okay? Okay.